In the previous lesson, we learned about energy. We learned that there are 7 forms of energy, and that those 7 forms of energy fit into 3 broad categories. Energy that can only exist in the parts of atoms, energy that exists in whole atoms as they move from one place to another, and energy that doesn't even need atoms to exist. We also learned that energy is the ability to cause change. And we learned that change is a very broad thing that can mean many different things. But in this lesson, we're going to talk about something that's sort of the opposite of that. We're going to talk about what can never change about matter as we study the law of conservation of mass. This law is going to tell us something that can't possibly change about mass. Let's take a look at the law of conservation of mass, and then we'll look at a visual example to help us understand it. The law of conservation of mass states that matter cannot be created or destroyed. You can't just make extra atoms or obliterate atoms from existence. That never happens as we observe matter in the real world. What can happen is matter can change its properties by changing the way that the atoms are bonded together. That's what we do witness in the real world all the time. Now, I need to make sure I'm absolutely clear on what I am saying and what I'm not saying. God can create matter. God can suspend the laws of nature if he wants to and do things that we call miracles. So God could speak into existence with his words all of the matter in the universe. Using God's power, Jesus was able to feed 5,000 plus people with just a few loaves of bread and a few fish. Those sorts of miracles don't really apply to the law of conservation of mass, because in those cases, God wasn't tied down to the laws of nature. He was working beyond the laws of nature. But what the law of conservation of mass says is that as scientists study the universe, they haven't witnessed a case where matter has been truly, completely obliterated and destroyed, or that atoms have just been created out of nothing. That's the law of conservation of mass. You can't just create or destroy matter so that it comes from nothing or becomes nothing. Let's take a look at what this means for real-world substances. This is a picture of a molecule of a substance known as C4. C4 is an explosive substance. It's actually made up of a whole bunch of different substances put together. This is one of the molecules of the explosive in C4. And you'll notice that this molecule is made up of a bunch of atoms, and we could just count the different kinds of atoms. So the chemical formula for this explosive substance is C3H6N6O6, which means there are 3 carbons. You can count them up. Those are the black atoms in this molecule. There are 6 hydrogens. Those are the tiny white atoms in this molecule. 6 nitrogens, those are the blue atoms in this molecule, and 6 oxygens, the red atoms in this molecule. Now, because C4 is an explosive substance, what we know about it is that the bonds, even though they're stable, they're not very strong. Because if the bonds were strong, this substance would stay bonded together. It wouldn't release a whole bunch of energy as it becomes something else. So we can easily break the bonds of C4 by adding energy to it, just enough energy to overcome those bonds, and then it releases a ridiculous amount of energy as it explodes. Here's what the process of C4 molecules exploding looks like. They change the way that they're bonded and become different substances. That was a chemical change related to chemical energy. We broke the bonds that had chemical energy, and we formed new bonds with a different amount of chemical energy. What are these new substances that we have? Well, we can actually list them. We have 3 nitrogen N2 molecules. We have 3 water molecules, H2Os, and we have 3 carbon monoxide molecules, which is just a black carbon bonded to a red oxygen. So we made 3 new types of molecules in this chemical reaction that we just did. So what happened here was a huge amount of energy was released from the chemical energy that was stored up in the C4 molecule. But what didn't happen is we didn't lose any of the atoms that we had before. We just bonded them a different way. Let's take a look and see if I still have the same number. Do I still have 3 black carbon atoms? 1, 2, 3. Yep. Do I still have 6 little tiny white hydrogen atoms? 1, 2, 3, 4, 5, 6. Yep. Do I still have 6 nitrogen atoms, the blue ones? There they are. And do I still have 6 oxygens? Can you count up 6 red atoms in this picture? I didn't lose any of my atoms. I didn't create or destroy matter. Even with this highly explosive substance in a big explosion, I didn't lose atoms. I just changed the way that they were bonded. The law of conservation of mass predicts that that's what's going to happen when a chemical change occurs. Chemical energy is exchanged, it gets released, but the atoms themselves aren't created or destroyed. They just change the way that they're bonded to one another.